Graphing these inequalities on the graphing tool, then we're going to draw our axes. Okay, we want to graph this expression. When we graph this, we kind of want to have some idea of the parts that we want. Okay, so in this case here, we should have an idea where the vertex is. So I'm going to use Viete's formula. Okay, so P is equal to negative of negative 3 over 2a, so it's going to be over 4. Okay, so our vertex is going to be at 3 over 4. Okay, so in this case it's going to be a positive 3 over 4. Okay, and when we plug in positive 3 over 4, we can get a y value. We don't necessarily need a lot of details, but we should have some idea where the vertex is. Okay, so I'm going to have my y-intercept at 1, my vertex somewhere around here, and there I have my graph. So the main idea though is, we want to know are we looking for the area above or below? So when we talk about the inequality, we want y is less than, so we want the y that is below. Okay, so we want that area in there. So then we need to figure out what values of k satisfy this inequality. So what values of x then satisfy this inequality? Well, in essence then, if I set this up, really I'm setting this up as a one variable inequality. And I really just need to know where the zeros of this one variable inequality are. Now there's two ways I can do this. I can set this up so I can draw y equals 6, okay, and figure out the values of y equals 6, but essentially I'm looking for these values here. Okay, so I'm just going to make this equal to 0, and then I'm going to see if this is in fact factorable. So if I do my little triangle in here, 2k squared negative 5, negative 10k squared, so that's going to be negative 5 and positive 2. So I end up with 2k minus 5, k plus 1. Okay, so then it looks like this, 2k minus 5, k plus 1. But basically I'm just solving this one variable inequality. Now you can do it a lot of different ways. You can use your quadratic formula, okay, but in essence I'm getting k is the boundary points are going to be when k is equal to 5 over 2. Okay, so that boundary point is going to be 5 over 2 here, and the other boundary point is going to be k equals negative 1. So negative 1 here. And I can do this entirely on my graph by drawing in this horizontal line. But again, in essence, I want to know where is this graph bigger than or above 0. So it's above 0 in this region here. Okay, so it's going to be this region here. So it's going to be this inequality. So it shows up what are the possible values of k. So let's answer the question first. So k is going to be less than negative 1, and k is going to be greater than positive 5 over 2. Okay. And where does it show up on the graph? It is a part of the graph above y equals 6. Okay, and the boundary points are going to be at negative 1 and positive 2.5. So we did solve this algebraically. This problem really is just, can you identify this on the graph? So that's the main idea. Although we did solve this algebraically, do you understand where the graph is? Is it above or below? When I solve this problem of k, essentially I'm just finding where is the k. When I plug in 6 into here and k in for x, I'm just solving this one variable inequality, and the boundary then is where the k or y value is equal to 6. Okay, so take a look at this next one here. So if I graph this inequality, I'm going to draw the graph of this, put it in my graphing tool. Okay, and it looks like it's a parabola that's upside down. Okay, kind of looks like this. It looks like it has a vertex is going to be at 3 and 4. That's very important to recognize. Okay, it looks like it has zeros at, now the zeros look like they are irrational zeros, but we could find those zeros out. Since it's a two-variable inequality, I'm not going to worry about the zeros for now, but I want to know where the y is above. Okay, so this is greater than or equal to, so I want to know where the graph is above that boundary line. Okay, so there's my solution. Now the question is asking, if 3m satisfies the inequality, what are the possible values of m? Okay, so basically I want to know the y values are m that are going to be bigger than when x is 3. So I'm just going to plug that in. So m is greater than or equal to negative 2, 3 minus 3 squared plus 4. Basically I'm looking for where m is greater than 4. Essentially, I'm just looking at this one-dimensionally along the vertical line. Okay, so where is the value m going to be bigger than above this line? Well, it's going to start at 4 and be above. So it's going to be where m is equal to or greater than 4. Okay, and where does this show up on the graph? It shows up along the vertical line. Okay, remember this is one-dimensional, but because when we substitute in, we have a one-variable situation. It shows up along the vertical line at x equals 3.